An AI knowledge base is your own documents indexed, so a model can search them when a question arrives and answer from what it finds. Here is how that works, how to build one, and the ways it breaks. 3 things up front. First, your docs decide the answer. If the search returns the wrong paragraph, the model writes a confident answer from the wrong paragraph. Second, even the best published setup still misses the right passage about 1 time in 50. Third, if your whole policy set is 500 pages or fewer, you may not need retrieval at all. Here is the path. First, what it actually is. Then, how retrieval works, stage by stage. Then, where it breaks. Then, how to build one. And finally, permissions and proof that it is working. Start with the definition, because one word in it does most of the work. Here is the definition. Your documents are indexed, so a language model can search them the moment a question is asked. The top passages get pasted into the prompt. The model then answers from those passages instead of from its training data. Fix the document and the next answer changes. That is the whole reason this design won. An AI knowledge base does not replace a knowledge base. It is a new interface on top of one. Traditional search hands you a list of links. This hands you an answer. It retrieves a few hundred words instead of a whole article. The model does the reading, not you. When the content is wrong, nobody notices, because it gets quoted fluently. And a duplicate page stops being an annoyance and becomes a rival source of truth. 5 stages sit between a document you wrote and an answer a customer reads. 5 stages. Sources are everything you connect. Help center articles, PDFs, a website crawl, and if your tool allows it, solve tickets. Chunk and embed splits each document and turns every piece into numbers that carry its meaning. The index holds those next to a keyword index for exact strings. Retrieve and re-rank merges both lists and cuts to the best few. Then the model answers with citations. Chunking eats more engineering time than anyone expects. Anthropic's example is a chunk that reads, "The company's revenue grew by 3% over the previous quarter." It names no company and no period, so a question about one firm may never find it. The fix is to add a short description to every chunk before you index it. On Anthropic's numbers that cost $1.02 per million document tokens, one time. Anthropic published the numbers rather than the vibes. Measured as how often the right document misses the top 20 chunks, embeddings only fails 5.7% of the time. Add a description to each chunk and it drops to 3.7. Add keyword matching and it drops to 2.9. Add a re-ranker and it reaches 1.9%. That is the ceiling on a clean research corpus. Yours is not one. One thing to check before you build anything. Anthropic notes that a knowledge base under 200,000 tokens, roughly 500 pages, fits straight into the prompt. No vector database, no retrieval at all. If your entire policy set is 40 pages, you do not need infrastructure. You need a long prompt. Almost every failure here is a content problem, not a model problem. Failure 1, and almost nobody screens for it. A customer of ours ran a bus tracking service. Their docs were written for the administrators who configured the system. The tickets came from riders asking where their bus was. Every article was accurate, current, well-written, and useless for the questions people asked. You only catch this by comparing your articles against real ticket history. Failure 2 is contradiction. Old documents about systems you retired still sit in the index, so the model cannot tell which version is current. Failure 3 is the pile underneath. As one Reddit thread put it, people treat business information like a junk closet and throw everything into a drive or a Slack. The model inherits all of it. 3 symptoms come up again and again, and the instinctive fix is the wrong one each time. Confidently wrong answers usually mean retrieval worked and the source sentence was absolute. So rewrite the sentence, not the prompt. If it cites an old policy, archive the superseded page out of the index instead of adding more documents. And if it misses order numbers or error codes, turn on keyword matching next to the vectors. 4 steps, in the order that saves you the most rework. Start from questions, not documents. Cluster your last few hundred tickets so you know what people really ask. Then pick a small subset of documents, 1 canonical page per topic. Do not connect the whole drive. Then test known bad questions before anyone sees it. 1 stale policy, 1 duplicate FAQ, 1 ambiguous question. Then roll out on a ladder. Dashboard first, then drafts a human approves, then live answers. One step people skip: your behavior rules sit apart from your knowledge. Knowledge is retrieved only when it is relevant. Behavior is always on. Tone, when to escalate, what to never promise, and what to do when it does not know. Keep them in two places, and after you connect a source, check what actually landed. Confirm the PDF's passed and nothing quietly failed a size cap. Two last things: who is allowed to see an answer and how you know it is working. The mechanism is called permission-aware retrieval. The connector pulls your content and the access list from the sources system. At query time, every candidate document is checked against the person asking. Two catches: Microsoft says access changes can take up to 24 hours to show up, and those updates land on a full crawl. Not an incremental one, so the index can feel current while revoked access quietly persists. Deflection rate is the metric everyone reports and the weakest one on its own, because a confidently wrong answer deflects beautifully. Split it in two. Were the right passages found at all, and is the answer supported by them? Azure and AWS both score those separately. The cheap version is 30 questions you know the answers to. Rerun after every content change. 5 should be questions it cannot answer, and those 5 are the important half. 3 things to take away: your content sets the ceiling, so a smaller and cleaner corpus beats a bigger one. Even the best published setup lives with a miss about 1 time in 50, so plan for the miss. And 30 known questions, rerun after every change, tell you more than any dashboard. If that cleanup sounds like a lot to do before you learn whether this works, that is the problem eesel is built around. It connects your help center, your docs in Notion, Confluence, or Drive, and, unlike most built-in helpdesk AI, your solved tickets. Then it replays hundreds of past tickets and hands you a gap report before a customer sees anything. Low confidence routes to a draft for review. Connect a source and run the simulation without a credit card. Pricing is per ticket rather than per seat, with $50 of free usage. The full written guide is linked in the description.